Okay, now we had already seen in the previous videos about differentiation and integration. Now we will see what a differential equation look like. Now differential equation, that means a differentiation is there, that is what a derivative of some function is there. Now let's see what does this exactly mean. Now we have seen about for any function y, or I say f of x is equals to some y, which is also a function of x. Now if I'm finding a derivative of it, d by dx of y of x. Okay, also it is y dash, I can see. Now whatever the answer comes, I can differentiate it again. For example, if there is a function y of x is equals to x cube, I will get my d by dx of y of x as derivative of x cube, and that will be 3 into x square. Okay, that is what, which formula, n x raised to n minus 1 formula. Okay, now if to this answer, if I differentiate this again, that is what, if I go to find the derivative of that 3x square, what will be the answer? 3 will come out, and d by dx of x square, that is what, 3 into the derivative of x square will be 2x, that is 6 into x. Okay, so I can differentiate this again. So basically this is what, it is the derivative of this 3x square. Okay, that is, it is the derivative of this part, that is what, it is the derivative of this derivative d by dx of y of x. Yes or no? Okay, so this I can just represent as d, d into d, therefore d square, to dx square y of x. So looking at this, you understand that this is the second derivative, second order derivative we see. That is what, you have differentiated this y of x once, you have got y dash of x, and then this y dash of x you have once again differentiated. That is, you have differentiated it two times. Okay, so you have found a derivative, and of that derivative again you have found a derivative. Now, so this one, this 6x, I can say that this 6x is the second order derivative of this x cube. That is, once when you differentiate it, you get one derivative, that was this 3x square, and then again you differentiated this 3x square and you got the derivative 6x. Therefore, it's a second order. Now, if you differentiate this 6x again, okay, now this 6x is also a function of x. That means obviously you can differentiate this again. Okay, so what it will be, if you are differentiating it again, it will be the d by dx, that is derivative of the second order derivative. That is d by dx of the x square y by x. That is what, d by dx of my 6x it will be. Okay, so it will be what, d by dx of 6x will be 6. And how you will represent this, as d cube by dx cube y of x. That is, for this y of x you have differentiated 3 times and you have got it 6. That's why this is called as third order derivative. Okay, so once you are differentiating it once, it is called as first order derivative. If you are differentiating the derivative again, it is called as second order derivative. If again you are differentiating, it becomes third order derivative, and so on. Okay, so first order derivative of any function y of x you write as y dash, the second ordered will be y double dash, third ordered will be y triple dash. Or it is same as first order d by dx of y, or d square by dx square of y, or d cube by dx cube of y. Okay, and so on. D raised to 4 by dx 4 by y, and so on. Okay, the fourth order derivative. Like this, you can just find out. Now, if you here in this example, if you find a fourth order derivative, okay, the d4 y by dx raised to 4, it will be the derivative of this again 6, and the derivative of constant is a 0. Okay, now I just see find third order derivative of x square. So first order derivative, you will have to find d by dx of x square, that is your 2x. So this becomes first order derivative. Then d by dx of the derivative, that is what, 2x. So derivative of 2x will be 2 into derivative of x, and that is 2. So this becomes your second order. Now you have to find one more. So this is basically d square by dx square of x square. Now you have to find a d cube by dx cube of x square, and that will be what, the derivative of this. So d by dx of 2, and that is 0. So this becomes my third order derivative. Okay, so this is how we find the derivatives. Now this was about the or higher order derivatives. These are called as higher order derivatives. First, we already had dealt with the first orders. Now second order, third order, fourth order, they all are higher order derivatives. Now suppose in any kind of derivatives we have some equation, an equation. Now see, we have this equation x plus y equal to 0, x square plus 2x plus y equal x square plus 2x plus 4 equal to 0, and so on. Okay, so these are my linear equations in two variables. Then this is my polynomial equation, or even I can say quadratic equation. Now similarly, I have something called as differential equation. Okay, and in that the derivatives are present. For example, if we take any function y, then the function of this is present, that is what, dy by dx plus d square y by dx square equal to, let's say, 2. Okay, that means what, here a derivative is present, its derivative is again present, and so such kind of equations are called as differential equations. Now for example, y is equals to 0, this is not a differential equation, but if I write this as dy by dx equal to 0, this becomes a differential equation. That is what, a derivative of that, or a derivative of any function is present. Or even if you write as d cube y by dx cube is equals to y, this is a differential equation. Okay, now something called, or even like this, y triple dash, no, y triple dash is equals to y, this is a differential equation. Now once we have known what is a differential equation, there comes into picture something called as order and degree of a differential equation. Okay, now order and degree of a differential equation, let's consider this differential equation. Now, if you see this first derivative, it is the first order derivative. Okay. If you see this is the second derivative, the second derivative is the second order derivative. Okay. And this is not a derivative. So we are not considering this. Now, out of whatever the derivatives which are present here, one is first ordered, one is the second ordered. So which one is the highest order derivative? Highest order means the second order. Okay, one is first, another is second. So the highest order is second, or the highest order is 2. That's why the order of this equation is called is order is 2. Okay, now if you see this equation, highest order derivative, only one derivative is present, and that is of degree 1, sorry, order 1. Okay, that is only first derivative is there, so order of this is 1. Now if you see this equation, here also only one derivative is present, that is d cube y by dx cube, but it is the third order derivative. Okay, so order of this equation is 3. So if we see here, if I say d cube y by dx cube plus dy by dx is equals to 7x. Now this one is the first order derivative, this one is the third order derivative, but which one is the highest? First or the third? Third one is the highest one. So that's why the order of this equation is 3. Okay. Now something called as degree. Now for example, let us check. If I have one more equation, d square y by dx square plus dy by dx the whole square equal to 1. Now in this equation, if you see, this one is the first order derivative. It is, there is a square there outside, but it does not matter. The highest order the derivative here is dy by dx, that is the first order derivative, and here the derivative is of the second order. Which one is the highest? 2. That's why order is 2. Now for finding something called as degree, we have to look for that highest order derivative which is present there. Now which one is the highest order? This is the one, okay, whose degree order we have mentioned. So now let's check. This one is something like d square y by dx square raised to the power 1. Okay, obviously no, it is raised to the power 1. So degree is that power to which the highest order derivative has been raised. Okay, so degree of this becomes 1. Now if you see here in this example, this is dy by dx raised to 1. Here it is d cube y by dx cube raised to 1. So here also, although the degree, although the order is 3, the degree is 1. The highest order derivative has been raised to 1. If you see here, d square y by dx square the whole square plus dy by dx the whole cube equal to 0. Now here if you see, the highest order derivative is this d square y by dx square. So order is 2. And if you see, that highest order derivative has been raised to the power 2. That's why degree is 2. Okay. So this was about the order and the degree. Now if my y of x is equals to e raised to x, what will be my y dash of x? That is dy by dx. The derivative of e raised to x is also e raised to x. Okay, so that means if I write here dy by dx minus y of x, what it will be? E raised to x minus e raised to x, and that will come to 0. That is what dy by dx minus y of x is equals to 0. That is what I have got an equation. Okay, so now basically y, I can say what, if I substitute y is equals to e raised to x, this equation is satisfied by this y is equals to e raised to x. Okay, that is what I can say, that y is equals to e raised to x is a solution to this differential equation. So now if any differential equation has been given, let us see how to find a solution to this. Now let's take an example of dy by dx is equals to x. Let's take this example. What I will do here is, there is a term containing y, there is a term containing x. Both are different variables. Now what I will do is I will just separate out all x terms together and I'll separate out all y terms together. Okay. So what it will be, if I want to separate out all the x terms and y term is only dy, and all these x terms I will take this dx on this side. Okay, that is cross multiplication. So it will be x into dx. Okay. One thing, never write this as dx into x. Okay. See, whenever we are writing the integration, there is a function first and then the dx. Always. So again, if there was anything else also, this is like 1 into dy. So don't write this anything as dx into x or something. It should be always all the terms first and at the end it should be dx. Similarly, if you are writing about dy, all the terms should be first and then there should be this dy term. Okay. So if you, in the same equation you want to write something, write it like this: dy plus whatever it is but dx. So don't combine everything together, but this dx should be always at the end. They should be the tail of whatever you are writing. Okay. So now coming back to this, once these things have been separated, that is y has been separated, terms has been separated, that is what this is called as variables are separated, or variables were separable. So we call this as variable separable form. So once the variables have been completely separated, we have to integrate on both sides. What we will do integrating, in the sense, integral of this dy, that means 1 dy, is equals to integral of x dx. And we have seen integral of dy. Now instead of dx we have, instead of x we have y. Okay. So that means what? We are going to integrate this. This is same as what? Y raised to 0 dy. Okay. And what is this y raised to 0? Compare, if we compare this with x raised to n dx, what is this? Instead of x, there is y. So everything will be in terms of y. Okay. Now, also, the answer for this was x raised to n plus 1 upon n plus 1 plus c. Okay, so that plus c is coming here, and y raised to 0. In place of n, we have 0. So what we will come? Y raised to 0 plus 1 upon 0 plus 1 plus c. That is what? Y plus c. Okay, so derivative of this is y plus c is equals to x. Integral of x dx is what? This is of the form x raised to 1 dx. So it will be x square by 2 plus c. That is what? Y is equals to x square by 2 plus a constant. So now yes, you will say that this c and this c will cancel out, but please don't cancel out that. Instead you can just write it like y, integral of dy is y, integral of x dx is x square by 2, and in the final answer you can just add a c there. Okay, at any side. This is even same as y plus c is equals to x square by 2. Okay, so that c is independent of all your signs, positive, negative, it does not matter what it is. Okay, so this becomes your final solution to this, or even this is your final solution. Okay, anything, it can have more than one solution. Even if you find those values, no, it will be same, one and the same. Okay, now let's take another example. Second one, dy by dx is equals to, if you see, e raised to x. What I will do, I want to separate out the variables. What I will do, dy is equals to e raised to x. I will take this on the other side, that will be dx. that is in the variable separable form. What I will do here is I will integrate dy is equals to integral e raised to x dx. Integral of dy we have seen y is equals to integral of e raised to x we have seen, that is e raised to x, and a constant of integration added on any side, that is plus c. Done. This is the solution. It's very simple. Okay. If you see a third problem, I'll take an example. Dy by dx is equals to x square by y. Now this one is also in the variable separable. See, this y can be brought on this side. This x can be taken, dx can be taken on the other side. So it will be what? Y dy is equals to x square dx. Now the variables have been separated. What I will do is I will integrate. Integral of y dy is equals to integral of x square dx. The integral of y dy we know it is y square by 2, and we know the integral of this is x cube by 3 and a constant plus c. Okay, so this one is a solution, or you can write this as y square by 2 plus c is equals to x cube by 3. So at any place you have to just add c. Either it can be on this side or it can be on this side. Okay, anyway, so either this is the solution or this is the solution. Okay, or even you can add it on both sides. Y square by 2 plus some constant c1, they both will be different, and x cube by 3 plus some constant c2. This is also fine. So any form it is just fine. Okay, so this is how we find a solution. Okay, so even if you keep it this much, or even if you write it like this, or even if you write it like this, it is one and the same. Okay, so it does not matter. Don't go to simplify the things. Only thing is you have to make sure there is no derivative present in whatever you are finding as the solution. Okay, now this was about the finding solution to the differential equation. A question can come, solve the following differential equation. That means what? You have to find something for y. That is what you have to do, the things like this. Okay.